Hello everyone, welcome back to this session all about protecting our forests. I'm here. As you can see, I've made a quick dash from the ocean to the rainforest. And we're talking today all about trees. So as you've heard in some of our earlier sessions, trees are vital for the health of our planet, but they also help us to lock in carbon. They lock in carbon in the trunks, but also in the roots and in the soil systems around them. So trees are critical. And we heard a little earlier from some of the BBC Science team about what we can do for climate change. And one of the things that they recommended was plant some things, plant some local native species, even if it's in a window box, or plant some trees. So that's what we're going to be talking about today. We have some really exciting guests coming to join us in this session, but we're going to start by going straight on to Professor Richard Lucas, who's going to give us an introduction. So over to you.
Good morning. I'm Professor Richard Lucas from Aberystwyth University, and I'm speaking to you today from the Centre for Alternative Technology near Machynlleth in Mid Wales. Welcome to Protecting Our Forests. Today, I'm going to take you on a tour of the world's forests, from sea level to the high mountains, from the tropics to near the poles. I'm going to highlight their biodiversity, the plants and animal species that live in them, the carbon they contain. Then I'm going to show how Earth observation data from satellites and aircraft have been used to help us understand how those forests have changed and how they've been lost and degraded, but also how they're regenerating as well. We're going to give you a positive outlook on the planet, show you what you can do, and highlight the real benefits of having forests back in our lives. So, let's go. To many, a forest is just a forest, a collection of trees. But unfurl their secrets, learn their patterns, and a whole world of rich, unparalleled beauty is revealed. Forests are just alive. They breathe and move and they shift. The variety of forests in all their forms is extraordinary, changing between those hugging the coast to those nestled amongst the highest mountains, and in the transitions from the hot, wet tropical regions to areas plunged into darkness for half of the year. Gradients that exhibit remarkable parallels. But even forests of the same type can look different depending on where they sit. Oak trees on an exposed windswept hill contrast with those sitting in a calm, sheltered valley. Twisted, gnarled branches versus proud, upright trunks. But it's not just the trees that make a forest. Mosses, lichens, liverworts and ferns cling to humus branches, fed by tumbling flows of water. Shrubs and other plant forms coat the understories. Starting at sea level and on the equator, we're going to take on a tour of the world's forests. Mangroves are found at sea level in the tropics and subtropics, extending to temperate regions in the United States and Australia. Humid, wet tropical forests are found on either side of the equator, mainly in Central America, South America and Southeast Asia, but also extend to the subtropical zones. Where conditions are drier and often more seasonal, savanna woodlands are found, with these occupying large areas of Africa, South America and Australia. Mediterranean-type forests also occur in dry areas of Europe and in North America and Australia, and are mostly evergreen. Temperate forests are found in the mid-latitude, including here in the United Kingdom. They are either broad-leaved, shedding their leaves in the autumn and regaining them in the spring, or needle-leaved, most of which keep their leaves throughout the year. The boreal forests cover vast swathes of land in the regions towards the poles, and consist mainly of conifers, but also of birch and willow. Where it is too cold, the forests give way to the tundra, bare rock, snow and then ice. Forests are teeming with life, measured in terms of their biodiversity. As a general rule, diversity is lowest in the boreal zones and greatest in the tropics. We are perhaps most familiar with large mammals and birds at home, but also those living today in the vast savanna woodlands. But other life forms also rule these places. Invertebrates, ants, butterflies, moths, worms, but also bacteria and fungi.
Mangrove are really efficient at pulling carbon from the atmosphere. They do this by pulling the carbon down into the biomass, into the leaves, the sticks, the trunks, and down into the roots and the pneumatophores as well. When they do this, they're actually pulling carbon from the atmosphere that would normally stay there and contribute to climate change. Because the mangrove and salt marsh areas are both wet quite frequently because of tides coming in and out, and because it's saline environments, often when they pull that carbon into the biomass and then down into the root zone, that carbon stays in the root zone for a very long time. And this is what we call carbon sequestration.
Forests are the lungs of the earth. Whilst we take in oxygen and breathe out carbon dioxide, the trees take in carbon dioxide and send out oxygen. An essential, vital cycle for life on Earth. But this cycle has been broken. As humans spread out across the globe, they learned to extract from the forest timber for fires, houses and tools, plants for medicines and foods. Initially, forests were hardly affected, and many societies developed ways of caring for them and sustaining them for themselves and future generations, but not all. As tools became more advanced and efficient, and our insatiable appetite for resources grew, many of the world's forests became lost or damaged. Even Iceland once supported forests until the Vikings arrived. Here in Wales, forests stretched out across the country, following the retreat of the ice sheets over 10,000 years ago. But now, these forests are confined to small, isolated fragments. The loss and degradation of forests here occurred many centuries ago, but recently has been happening faster and over larger areas across the world. Many areas continue to be cleared for agriculture, for crops and grazing animals. Roads have been cut through the forests, increasing access to previously unreachable areas. Forest cover is now at 37% of what it was before, and this number is decreasing every day. We can see these changes through a time series of satellite imagery, including that provided by the European Space Agency, or ESA. Their climate change initiative, amongst others, is showing how we can measure the losses of carbon that occur when forests are cleared or degraded. The Living Earth project is changing these observations into maps of land cover across successive years, providing new insights into how humans are impacting on forests.
Planting and regrowing trees can help to increase the carbon stored in the vegetation around us, including forests. We can measure how much carbon is stored and is accumulating in forests using field data, such as here in the forests around Berlin. Satellite data helps us to give a bigger picture of the forests across the world. Our research has shown that in the tropics, the carbon absorbed by the regrowing forests is currently only enough to balance about a quarter of the carbon that is released back into the atmosphere due to deforestation, logging and fire. It is therefore vital that we protect the existing forests as well as plant and regrow trees and forests in the right places. Working with local communities can ensure these forests remain standing and healthy for many generations.
The loss and degradation of our forests has released hundreds of millions of tons of carbon dioxide into the atmosphere. Coupled with the even greater release of these greenhouse gases from the unrelenting burning of fossil fuels worldwide, the climate is changing. When you damage one part of a delicate cycle, the others are soon to suffer. With higher temperatures and less rainfall, wildfires are increasing in frequency and intensity, destroying the places that we once used to enjoy and removing our crops, livestock and biodiversity. The flames cause direct damage to forests, but the smoke can also make the air difficult to breathe. In the Australian fires of 2020, many animals and large amounts of carbon stored in the trees and soils were lost. While fires are often an important and usual part of forest functioning, they are now happening far more than they have done in the past, and the forests are not being given the time to recover. In addition to increased wildfires, the loss of forests and their ability to maintain a stable environment around them has led to increased pollution of many of our coastal and inland waters. Change in our climate everywhere, but the most intense in our mountains and polar regions. Glaciers and ice sheets are melting, causing sea levels to rise globally. This, along with the changing climate, is leading to more frequent and more intense storms. We have damaged our Earth, and we are beginning to feel the repercussions, but it is not too late. Forests, in all their splendour and majesty, will not go so easily and have one last trick up their sleeve that may prove to be the key to averting the crisis we are heading directly into. Forests can regenerate. But they need our help to do so. We can take from the forest if we allow them to regrow and effectively plan how we can extract the resources they provide without causing damage. Projects such as the European Space Agency's Climate Change Initiative and Living Earth can help us to plan for the future, finding pathways that can best restore our forests and reverse the declines we have all seen in our lifetimes.
G'day, I'm Dr. Peter Scarth. I'm standing here in the heart of Brisbane, Australia, where we have this magnificent natural gem known as Karawatha Forest. 50 years ago, this beautiful forest was at risk of being destroyed by urban development. Thankfully, due to the tireless efforts of dedicated individuals, it was saved from destruction and declared a conservation park. Today, it serves as a sanctuary for over 200 bird species, unique reptile and mammals such as spiders and sugar gliders, and a diverse wetland ecosystem teeming with life. The restoration work that takes place here is a real-life example of how we can combat environmental degradation and protect our planet's biodiversity.
The solution is there, but we need to change, and we need to change now. And we are changing. The United Nations Decade on Ecosystem Restoration and the 2030 Agenda for Sustainable Development are giving directions that can help halt and reverse the degradation of ecosystems on every continent. They are aimed at combating climate change, preventing further loss and extinction of species, and decreasing the carbon lost through our use of the Earth's resources. You can also help by learning about forests and how they are sustaining life on Earth, planting trees or making sure that those in the ground remain there. There are also ways in which you can contribute to the mapping of forests and monitoring of change from satellites. For example, the Living Earth EarthTrack mobile application allows you to collect information that can validate these maps so that we know that what we see from above matches what is actually happening on the ground. This simple contribution helps us to better track where our forests are and what state they are in. Let's make you the generation who reverses the trend and stop the loss of nature and our vital resources. We can achieve this, but everyone needs to play a part. We are one people and we have one home. Let's work together to make the future bright, safe and prosperous for all who walk this earth. Welcome to the Living Earth Centre, which is at the Centre for Alternative Technology in Mid-Wales. And this exhibition was really developed to try and show people how satellite data have provided us information on how we've used landscapes in the past, what their current state and functioning is today, and also to plan the protection, restoration, and sustainable use of resources. There's a number of projects I'm going to showcase to you today. One of these is the European Space Agency's Climate Change Initiative. And our Biome project is producing maps of the world's carbon content in forests. And here you can see we have the white, which is no forest, and the green, which is very high biomass forest, lots of carbon in there. And if I take you out, you can see this is an area of Brazil, and you can see where the deforestation has happened here. And this is the river Amazon, but a lot of that is starting to be cleared. Okay, it's been cleared over the decades. The Global Mangrove Watch is using similar data to try and produce maps of the extent of mangroves around the world, and also how they change, because they're very important, because they have huge amounts of carbon, and they've got lots of species of animals and plants in there, so they really need preserving. So monitoring those is ongoing. Then we have Living Earth. And Living Earth is an approach which uses satellite data to construct land cover maps over time. So what we do, this is applied to Wales, we take the satellite data, analysis-ready data, we retrieve or classify what we call environmental descriptors, such as canopy cover, biomass, forest species as well. Then we map those, and then we can monitor both the land cover and those variables over time to produce maps of change. Then we work out the causes and the consequences of that change. Finally, we can use a mobile app to validate these maps, and that helps us to make them better. Here's an example of the map for Wales, and you can see there's lots of detail. It's 10-meter resolution from ESA's Copernicus satellites. And you can see the whole of Wales, and we can do things like crop types and forest types. see whether it's broadleaf, deciduous, and so on. So it's really exciting. We can do that for multiple years, and we can also look at change routinely. Our mobile app, we have lots of points, and they collect information on the land cover, the same as what we've been mapping. So we can use those to test how well our maps are doing. Have we classified everything correctly? Wales has the same land cover classification system as Australia at the minute, because we developed it in parallel. And again, we can sort of start to see for 33 years the change in the Australian continent. But what's happened, the fires, the urban areas, the mining, all sorts of things, what's happened in the past. And so we can start to see how can we make that better into the future. And again, we have the mobile app points that work right across Australia and help us to say, have we got it right? And can we use that information to help us improve in the future? So it's very exciting. We have lots of information, lots of tools. This is just a sample of what's available. And so explore the website, they're all open, and really look forward to seeing you in the question and answer.
That is wonderful. Thank you so much to Richard for providing all of that rich information. I think it's just fascinating to think about how satellites can be used. We've talked a bit about tracking plastics in the ocean, maybe tracking marine mammals, and now we're talking about trees and deforestation. It's also really nice to end on a note of optimism, I think. So yes, forests are being cut down, but there are things that we can do to combat that, whether it's going on these apps to help validate the satellite data or planting trees ourselves. It's nice to have some action that we can take. So thank you very much, Richard, for that introduction. And if you want to ask him a question, just pop your question in the box on the right-hand side of your screen there, and it'll pop up for me. And if I have time, I'll certainly ask as many as I can at the end. Right now, though, we are going to head live to some scientists at the Eden Project. Are you there? Looks like
Hello.
it, but hi, can you hear me? Yes, we've got you. Go ahead.
Excellent. So welcome to Eden Project here in Cornwall, and thank you for having us with you today. My name is Robbie. I work on the schools team here at Eden Project, and we also have Tom with us as well. You might see Tom as well at the Q&A at some point. So for any of you that aren't familiar with Eden Project was built in an old China clay quarry. And we didn't have any plants or any soil or anything in here. It was just a big, empty, ugly hole in the ground. But we transformed that into a living theatre of plants and people. And we have a giant indoor greenhouse. So we have the largest rainforest in captivity here at Eden Project, which I am actually stood in at the moment. Now, Eden Project is all about connecting people with each other and the natural world to show how we can work together to build a better, brighter future. Now, as I said, I'm currently in the world's largest rainforest in captivity, and I'll show you around a little bit, and I'll flip the camera around a bit in a moment as well. But this rainforest biome is 55 meters tall. It is over 2 football pitches in terms of surface area. And a good statistics for you guys, well, a sad statistic, but a striking statistic for everyone to remember is that we lose an area of tropical rainforest the size of this rainforest biome every 11 seconds due to deforestation. So it's a really sort of stark statistic, but it's important to realise. But more important as well is to realise what we can all do to be part of the solution to that. So tropical rainforests are so important for so many different reasons. But what I want to do now is to just give you guys a little bit of a wander around and just pick up on some of those reasons about why rainforests are so important and why they actually matter to everybody, everywhere, wherever you live in the world. So I'm going to flip my camera around here a bit so I can give you a better tour. There we go. And I'm going to just show you some of those reasons. Why are these places so special? So for starters, and the first few things I'm going to say, I guess they're very human-centric because rainforests are important for so many reasons, and they're very important for people. So I'm going to start with some of those reasons, but we're also going to talk a lot about some of the other reasons rainforests are important too. But if you think about it, we are all buying and consuming products that come from tropical rainforest regions all the time. So it doesn't really matter whether you live a long way away from a rainforest or not. We're all connected because we are all consumers of goods and materials. And for example, here in front of me right now, I have got coffee. So these are all coffee plants. And coffee is one of the most traded global commodities, food and beverage commodities on Earth. And I can actually show you some coffee cherries here. So these are the coffee cherries. They're red when they are ripe. And that is where coffee comes from. And I may be able to squish one open. I did one earlier on. Here we go. Squish one open. And when I do that, you'll see that inside a coffee cherry, you have 2 coffee beans. Here you go. And that one's covered in ants. So coffee, a really valuable traded global commodity that wakes people up every day, that comes from tropical rainforests. We've got nutmeg. This is a nutmeg tree in front of us. So lots of our wonderful spices that we love come from tropical rainforests. And we have turmeric, another spice. So here's our turmeric. So in this little part of our biome here is called spice because there's loads of really fragrant, spicy plants here. And I kind of wish that this was smell-o-vision, because if I take a little bit of this plant, this is lemongrass. I crush it up with my fingers here and smell it. You can't smell it, obviously, sorry. It just smells absolutely amazing. It smells like those sherbet lemon boiled sweets. So lots of our food comes from rainforests. We've got in the background here, we've got, so I'm not going to make my way up to them, but we have our cacao plantation. So cacao gives us our chocolate. Again, a really important global commodity that comes from tropical rainforests that millions of people rely upon for their livelihoods as well. And banana is obviously another really big one. So food and drinks that come from tropical rainforest. But it's not just food and drink. It's also lots of materials and non-food products come from our tropical rainforests. So I could just show you behind me here, hopefully. I've got some giant bamboo above my head here if I pan the camera. So this giant bamboo is absolutely massive. And it's a really good example of a non-food product that comes from tropical rainforest. You can build it, you can make furniture from it, you can make it into material for clothing, you can eat the stuff, okay? So a non-food product. We also have a rubber plantation, which is up in the distance behind me here. You can't see those, you can see the rubber trees in the distance there. Obviously super important because we use rubber for all sorts of things, rubber gloves, tires, shoes, many, many uses. And I imagine that you have heard about the issues to do with palm oil. So behind me there, that big palm you can see, if I pan up, that big palm that's sort of in the center, that's coffee again, sorry. In the center of your screen there is an oil palm. And oil palms give us palm oil, which is an incredibly useful material, but very sadly is responsible for an awful lot of tropical rainforest deforestation. And so we need to really think about consuming sustainably produced palm oil. And it's not just those products, it's also things like medicines. So if I zoom along here through our biome, I'll be able to show you a super important tropical rainforest medicine plant, which I've got to say actually doesn't look very special. It doesn't look special. Actually, this plant, which is called Madagascar periwinkle, I'll flip the camera around so you can see it, actually gives us 2 really important cancer-fighting chemicals. One of the chemicals from this plant, which is called vincristine, is used to treat leukemia, and it's actually taken survival rates from some forms of leukemia from 10% up to more like 90%. It really makes me wonder, you know, how many other plants are there in our tropical rainforests globally that we don't even know what they are yet, let alone whether they happen to contain life-saving medicines. So lots of medicines and cosmetics find the roots of those medicines and those chemicals and those cosmetics are the tropical rainforests. Now, as I said, that's really only the tip of the iceberg. And things I've mentioned so far have been really focused on what rainforests give us. But actually, rainforests are really important for a whole host of reasons, way beyond the things that they might give us where we live. They provide homes and livelihoods for people across the globe. They provide habitats for a massive amount of species. Tropical rainforests have the highest biodiversity of any ecosystem on Earth. So they're incredibly important as a store for this genetic information, this biodiversity. And that is despite the fact that they only cover about 2 to 3% of the Earth's surface. So there isn't much tropical rainforest, but it is full of life. They're also super important because of the role they have in regulating the Earth's climate and weather patterns. Forest, and I know that we've been talking already today about mangrove forests and tropical rainforest. They have a massive capacity to capture carbon dioxide from the atmosphere and store away, lock away that carbon dioxide and help us to fight climate change. Now, the last thing I wanted to mention today before I hand back was just a quick message on what we can all do where we live to help tropical rainforests and help with conservation. Because we know that tropical rainforests and forests in general are under threat on a global scale. But it's really important to know that there's loads of people and organizations that are passionate and doing loads of really great work to actually conserve and preserve rainforests for the future. And there's loads of ways that we can all help in our own lives, at home and at school. So here's a few ideas. We can think about our diet. We can remove deforestation from our diet, learn about where our food is coming from. And then once we've learned about that, we can make better and more informed choices. Look for things like fair trade. Okay. Fair trade might be a bit more expensive. So we might not be able to buy everything that's fair trade, and that's fine. But sometimes we can make choices that we know would be better for people and better for the environment. So look for things like fair trade or things that might have the Rainforest Alliance stamp on them. We can buy responsibly sourced products. Okay, so if it's wood that we're buying, we can look for the Forest Sustainability Council logo. So make informed choices about those products. Or if it's rubber that we're buying, find out where has that rubber come from. And also, it's really important that we support each other and other organizations that are doing good work to help rainforests. So at Eden, we're a strong supporter of an organization called Cool Earth, which is doing lots of great work to help people and communities that live in and around rainforests so that those people can look after the rainforest. Because the best people to help with rainforest conservation are those people that live in and around the forest. They are the experts on these places, and we need to let them take the lead and support them. Okay, folks, the last thing that's super important, I guess, is to have conversations. If you care about this stuff, tell other people what you care about and tell other people why you care and why it matters. Because the more we talk about these things and how important these environmental issues are, then the more it gains traction. It's like a giant snowball effect and everyone will get in on the action. Okay, folks, thank you. Hopefully that was a whistle-stop tour of the rainforest biome, and I showed you a few plants, and hopefully you've had a little bit of a think about why these places are so important and what we can do to help them. I'm going to hand you back.
That's great. Thank you so much for that introduction. We're going to have a Q&A session now, an extended Q&A session, because we have a lot of guests on the line joining us to answer all of your questions. So again, if you have questions you'd like me to ask, put them in the box on the right hand side of the microsite and I'll be able to see those, and I'll ask as many as I can in the time that we have. Just to start with though, Richard, I believe you have some colleagues on the line with us, so I thought we could begin with a quick introduction to some of the experts we have for this Q&A. Richard, do you want to introduce?
Yes, I'd love to. We have Viola Heinrich from Germany, we have Kaylee Rogers from Australia, and Peter Scarth from Australia. And so they've joined us for late into the night.
Oh, thank you so much for joining us, everybody live from Australia. We really, really appreciate it. I'm going to start, Richard, with a few questions about some of the things that you mentioned earlier. It's really sparked some conversation on the Q&A, which is great. Some people wanted to know a bit more about the techniques that you use, and maybe whether you use drones as well as satellites for some of your observations.
Yes, we use satellites primarily because they give you the large coverage of, say, Wales or Australia, but they're obviously operating globally. But we can actually then look in much more detail. You saw a lot of really nice drone footage of mangroves and all through the world, really. And that gives such powerful information that people can use to understand, what changes are happening, what the type of land cover is, and also to try and sort of get an idea of biodiversity, carbon amounts. And so that drone imagery is really important. But we can scale up, for example, our mobile app measurements through the drones and through to aircraft imagery, through to high resolution satellite and so on. Partly because when we do our mapping, for example, we use measures with units such as canopy height in meters or percentage cover, or categories like oak tree is always, number 33. And so if you use measurements with consistent units, they're completely scalable in space and time. So we could actually produce maps back to the Roman times, or we could go and produce one, way into the future. And that allows us to plan what we would like to see in the environment. And that's critical, because if we can make that information freely available, which we do for Wales and Australia, then we can start to sort of co-design how we want the world to look, how we can bring back our carbon, how we can bring back the biodiversity and make it better for people in general. So I think the living whales and the different techniques I've shown you have been fantastic. ESA has an amazing amount of information on pressures around the world, of what's causing changes. They're modeling climate, they're using the biomass information they're producing with them. And so there's a whole set of tools you can use, and most of them are freely available. And so we do encourage you to look at them, and it's very fascinating to learn about these, and to hopefully you'll be scientists into the future as well.
That's fantastic. I've just got another one to throw to you. People have been talking, and we've been talking a lot today, about things that we can do. And a number of people have mentioned thinking about planting more trees as something that we can all actively do to try to think about combating climate change. I just wondered, and there's a question that's come through actually around regrowth of forests. And I'm sure there's lots of things to think about in terms of what kind of trees we plant when we're going to go out and plant trees.
I think there's this it's sort of, the native trees are very good for biodiversity, because if you bring a non-native tree, for example, in, the biodiversity is much, much less, but they're much more productive often in terms of biomass. So it's what you want. So it's that sort of balance you have to strike. But certainly I'd encourage planting of native species as well, making sure that what you keep in the ground, it stays there. You really look after those forests, because they take decades, if not centuries, to recover. It's not going to be immediate when you plant something. It's not going to happen overnight. But you have to start and reverse this trend I've been talking about. And it's really important to encourage natural regeneration, plant in the right places, but consult and engage with people and talk to people and learn about forests and understand, what they do. I think that's really critical.
Fantastic. Thank you so much. I've got another one actually. This one is for Viola. We've heard about deforestation, and we saw in the images deforestation happening, particularly in the Amazon, in the example that Richard showed us. But what about wildfires? What contributes more to the loss of the forests? Is it fire? Is it logging? A combination of the two? Does it depend where you are?
Yeah, it definitely depends where you are. And in the tropics, actually, in the tropical rainforest, a lot of the fires actually often caused by humans, and then they jump over and cause impact on the forest. And due to ongoing climate change, we have more drought and less rainfall, and often these fires can then spread quicker. So actually we find that fire can have quite a detrimental impact on these forests, and sometimes it depends on how many trees you take out when you do the selective logging, and the impact of that. So when you have reduced impact selective logging, taking less can help sustain the forests for longer.
Fantastic, thank you. And one for Caroline next. Thinking about these mangroves, we've heard that tides inundate the land in some of these areas. What adaptations do mangroves have to allow them to survive?
I personally think mangroves are the best trees in a forest. Mangroves have to adapt to the waterlogged conditions that are created by tides, and those tides are often very saline, and that means that the substrates don't have a lot of oxygen in them. They're quite salty and they're often unstable. So mangroves have these really unique root structures. Each species has a slightly different shape. Some of them have stilt roots. Some of them have buttressing roots like rainforest plants. Some of them have pneumatophores, and these pneumatophores are like snorkels that bring oxygen into the substrate so that they can survive during those tides coming in. The plants also have to deal with the salt, and they will secrete the salt out of their leaves and out of the wood, or they might shed bark that has a lot of salt in that bark. So they've got a number of adaptations that allow them to thrive in this environment that no other tree can thrive in. So they're quite amazing trees.
And what benefits do mangrove trees have for us and for the environment that we live in? Why should we be protecting these trees specifically?
Yeah, mangroves provide a range of habitats for fish and water birds. Some of the fish, some of the smaller critters are really important for food webs that then support commercially important fish. So the fish that you are eating sometimes, particularly if you're in Britain, you're probably getting some imported barramundi, that they would get food that's connected back to mangrove forests via the food web. Those complex root structures that I talked about, they bind the substrate together and actually provide more support against wave action and start to slow down rates of erosion on shorelines. And the woody structures and the complex root systems can buffer wave action as well. So that provides a coastal protection service that's really beneficial for humans. Personally, I love a mangrove forested coastline and would much more prefer a mangrove forested coastline than a rocky, hard shoreline that's been fortified to stop erosion. So mangroves really provide a beautiful landscape that provides many services.
Wonderful, thank you. I've got one for Peter up next, actually. We've talked a lot today about satellite imagery and how important it is for protecting lots of environments, including forests. But how has this been used to understand and for conservation efforts in the Karawatha Forest Park over the years?
Karawatha Park is a nice little sort of urban park, surrounded by Brisbane. And so in the video that Richard showed, you can sort of see the urban development moving in around Karawatha. But it's been used as a long-term monitoring site for quite some time now. One of the favourite studies I think that we've done there is looking at this thing called the urban heat island effect, which is when cities get hotter than the forest because of all the buildings and the roads, and they concentrate the heat, whereas the trees keep everything cool. So we flew aerial imagery over there and we linked it back up to satellite data. And by looking at the satellite data, we could see how the trees in places like Karawatha Forest Park help cool down the entire city, or a very large area around it. It's kind of like the trees are like nature's air conditioners. So this discovery sort of helped us, I guess, realize just how important just retaining these urban pockets of trees, maintaining the forest, protecting these forests. And thanks to the satellite data, we kind of learned a lot about how we can keep the cities cool just by planting more trees and preserving the forests that we have.
Wonderful. We've had so many questions come in. We've had loads from our wonderful friends in Spain. So thank you to everyone watching in Spain. A couple of questions for the Eden project. The first is, what is the rarest species you have? And the second, do you have anything poisonous?
Ooh, yeah, I'm not sure about the rarest species that we have. Poisonous, yeah, we've got loads of poisonous plants in here. Most of those we tend to try and plant slightly further away from the paths. We've got the hura tree, which is particularly poisonous, that one. So yeah, we do have quite a lot of poisonous plants, and I suppose it's important to kind of remember that any plant, can be poisonous as well. So any plant you might come across, some plants contain medicines, and if you didn't have a particular medical condition and you were to eat that plant, that could actually not cure you; it could actually do damage. So yeah, there are quite a lot of poisonous plants in here.
Great.
But it's safe.
Take care in the Eden project, but they've got some exciting things. Just to wrap up, one more for Richard. So a lot of people have been writing to ask a little bit about how you determine the different types of vegetation using satellites. Maybe you can just briefly give us some idea of how this is done.
Oh, yes, I can. So often you can use things like structure, because obviously grasses are different from forests and so on. But we use spectral data, so that includes visible, that's the blue, green, red, and then the near infrared, which you can't see. And then we have something called the shortwave infrared. And if you look at all of those, they give you the colors sort of spring out at you from the satellite image. So you can classify the imagery from that. You can also look at the change in species and forests over time, for example. So you can pick out whether it's a deciduous forest, because obviously it's got no leaves in the winter, but lots of leaves in the spring. And then the conifers have leaves all the way through the year. So it's quite complicated. And because if you go to a tropical forest, it's so diverse. Sometimes you get like 800 species a hectare. So it's like you can't pick them out. And they're all in the understory as well, and multiple layers in a tropical forest, which is what's so rich. And that's what you saw, in fact, in the Eden Project. So it's, if they're monocultures like conifer plantations, yeah, that's pretty straightforward in a way. But it gets much more complex as you go towards the tropics, and you get that high diversity of species as well. And of course, as Kerry Lee pointed out, you have the water levels going up and down in mangroves, so they confuse also the discrimination of species. So there's lots of ways of doing it, and it's a big area of research. If anybody's interested, it'd be really good to go into that in the future.
Yeah, absolutely. I can tell people are interested because we've had so many questions come through. So if this is something that you're interested in finding more about, then think about a career in research and protection of our forests. It's a vital part of our fight against the climate change. So obviously you can follow up with a lot of the people that we've been talking with today, go to their websites, have a look, and we'd love all of you to get involved. That's it for this session though, and I'm sorry if I didn't manage to ask your question. There were so many that we couldn't get through them all. But we're looking forward to the next session and this afternoon now. So this afternoon we have a series of sessions thinking about protecting environments through STEM, talking with climate heroes and talking about careers of people in these disciplines. So if you're thinking about maybe a career in looking at Antarctica, looking at the forests, studying the oceans and marine mammals, then you'll have a chance to hear from people working in those disciplines. How did they get there? What did they study? Why do they have this lifelong passion for this subject? So do join us this afternoon for those. And of course, there's some after-school sessions as well for you to be involved with later on in the day. As ever, our hashtag is POP23. And of course, as I mentioned earlier, if you're a school and you want a climate ambassador to come and have a chat with you and do some activities, then there's a link in the chat that you can follow to request that. In a couple of minutes, we're going to move on to a space session. So do join me in a couple of minutes for that. Thank you.